jump right in. My thesis is going to be grappling with some pretty fundamental concepts of existence and reality. So if you see strange questions just flashing up left and right, that's kind of a result of grappling it. So I'm at the fundamental level. And I'll try to keep it right strictly to the thesis, which is, oops, sorry, I'm going to expand this. Okay. Assuming a discrete time universe and a powers ontology, and I'll define these terms. We need to posit discrete time as itself a causal power to avoid what Bill Williams has called the problem of fit for power ontologies in general. And if you hear a strange clicking of my feet, my shoe has been damaged, but it's okay, I'm going to fix it after the talk. Alright, to define these terms, by a discrete time universe, I just mean very simply, there's the smallest increment of time that's irreducible, it's the shortest time in which anything can happen. And for the sake of argument, we're going to have multiple of these so we can do things in this world. And let it be neutral to theories of persistence, like perdurantism and endurantism. Just assume that we can just be neutral about those and they're all fine. And the only reason to entertain this, for my purposes, is that quantum gravity says we might need to consider that the world is actually a discrete time universe. And I'm not going to explain QG or try to interpret QG. It's way too complex. One of the virtues of my talk, I think, is that it's a much simpler way to motivate real discrete time that's a power. So, that brings up what is a powers ontology, and this is just a universe in which some of the fundamental properties are irreducibly dispositional. And I'll give references about who supports this view. But even if you don't really believe in powers ontology, if you believe in dispositions at all, I think my thesis is going to create some problems. So, the problem of fit is by Neil Williams. The three basic tenets, which I'm just going to assume are pretty agreeable, that they've been well argued in the field and they're accepted by many people. Powers and dispositions intrinsic to their bearers, they're responsible for their own causal oomph, as he calls it. There's nothing else responsible for their causal oomph. Thesis 2, dispositions are defined essentially by manifestations, so even though it's not fundamental, if some of the possible world, if chlorine was not poisonous to humans, then it would be chlorine. So you define powers by their manifestations. And observation 3, manifestations often transpire together, they're mutual. Either they jointly produce an effect, or they're always producing a partial effect, and something else gives you this new effect. I'm not going to get into all the disputes about how that might happen, but many seem to agree this happens. And so the problem of fit is that none of theses 1 through 3 really explain why any two powers should ever cooperate. And so the analogy he gives is like, what if one puzzle company just produced a puzzle piece at random, and then another puzzle company, not communicating with them, produces another piece, and these pieces fit, not just with respect to their contours, but also with respect to the image that's taken on them. They form like part of the Statue of Liberty Road. That would be so incredible if the two powers fit. It's as incredible as when I strike my lighter and the butane and the oxygen decide to cooperate. Why do they cooperate? That's the problem of fit. So, what has been in recent literature coming to the fore, for this small part of the field, they propose that the powers contain a kind of blueprint within them. And this is a blueprint of counterfactual information by which they know all the possible combinations they can get into and what to do when they get into those combinations. So a few words on this. This is going to be part of the powers holism, whereas the essences of all powers are determined together at once in the beginning as a group, so that there's not really any learning going on. This is all pre-decided. Blueprints are information, which, as I said, how to manifest. And to get some quotes in here, Bauer doesn't say a lot about what information really is and what it could be. He gives a few pages. That's going to be a very involved discussion about what information is and how power might hold information. But he calls it physically real. There are primitive ontological differences, and these differences create possibilities for action, and that's why the powers, and since they're irreducibly modal, they're irreducibly creating possibilities. And Williams, in plainer language, just says, look, if you can just cram all the information into the power, it solves the problem fit. And so I'm going to call this operation cramming. The more information you put in the power rather than outside the power, it's a cramming operation. I'll use that terminology throughout. Okay, so my argument, the blueprint metaphor, I think I've observed these two authors, they rely implicitly, sometimes explicitly, on a notion that the time of this universe in which the powers work is continuous time. And as I've said, QG suggests it might be discrete. Now, without saying anything about QG, I'm troubled that these accounts are not equipped to accommodate discrete time. And if they aren't, we're going to have a major problem of fit in some powers that philosophers have already worked on a lot. And they are the electromagnetic powers that transpire per wavelength, like intensity and refraction, X-ray diffraction, radioactive decay, surface spectrum reflectance, just the reflectivity is bored, some things of power. And it's the kind of power that might even reduce surface color ontologically. I'm not going to go that far, but these powers are well defended in the literature, widely defended. So to restore fit, I'm going to say philosophers should add discrete time as a power to the blueprint. And so I'm right up front. I'm arguing to be less parsimonious. It's more parsimonious to not empower discrete time, obviously, than to say you kind of need to. All right, so just as I said, a lot of splashing going on with that thesis, but this is kind of how I'm going to proceed. I'll tell you about the problem fit. I'll tell you why status quo blueprints can't solve it. I'll show you my fit restoring blueprint, and I'll tell you what I think is probably the strongest objection. It almost made me shelve the paper, but then I thought more about it, and I said, no, I think I can still do this, and I think it's a good response. I'll show where Williams and Bauer stand with their commitments, and I'll look at more philosophy and physics to possibly answer what I'm doing. All right, the problem of fit for electromagnetic powers. This is the only graph I'm going to show today, and I know it's a lot to assimilate just on the fly, but this is the whole argument. So it's basically, it's aliasing distortion. And if you've studied information theory, you know that if you want to get, if you're receiving a signal that's changing sinusoidally, if you want to record the frequency content, you have to sample it twice as fast as it's coming in, or you're going to lose information. And worse than that, you're not just going to lose information, the signal will start aliasing. So you put on a disguise and tell you that it's propagating through the system as a lower frequency signal. And this is really, really bad, not only for communications engineering, but really bad for metaphysics and powers ontology. Because not even powers, they're not doing what their essences say they should do. Their manifestations contravene their essences, and that's totally devastating and a problem of fit par excellence. So this is just two signals. The orange is one signal, the blue is another signal, and they're being sampled every 10 milliseconds. And that's what the red dot is, the red dots. When you sample something, you just take whatever its amplitude is at that time. So you just take the amplitude and record it. And then later, you can lay out these amplitudes and try to infer what signal you had. And what you can see here is, if you just have these 10 dots, what signal are you going to think you have? You can really only infer you have the blue dot, because that's the one that's actually being traced. This orange one's going way too fast. You can't really tell that you've captured the orange one versus maybe something even faster. And that's because you're not respecting the Nyquist theorem, which is you must sample at twice the speed of the highest signal. So 100 hertz is enough to capture 20 hertz A. 100 hertz is not enough to capture signal B. That's what we see up there. So I've said that. Here's my metaphysical point, and this might be wrong, but I think it's very interesting to consider. If we get to a discrete time world where everything just happens in discrete steps, and that's all that is, and that's all that can happen, then it seems like those powers are only going to interact as if they were sampling each other. So they're not going to continuously exchange waves with each other anymore. They're going to discretely just share amplitude bursts. And so if you're just discretely sharing amplitude bursts, and that's all you get in the universe, and it seems like you are fundamentally and permanently susceptible to aliasing distortion. Anyway, as I said, this is the problem, is when if you take this system, start with a graph, and just send signal B, you're going to recover signal A, and that's a big problem for powers. Alright, so why would a statistical blueprint not account for this? I'm generally interpreting what a blueprint might look like, because the authors I'm studying have not provided one. So the powers of these circles, the power is a type of power that's being mapped out here, and Williams moves away from like stimulus conditions and let's paint the stimulus and let's paint, because we run into problems that Silas introduced, which I'll get to next. But anyway, you have two powers. Once they get in spatial proximity, then they work together. They're always ready to work together, and they manifest a new mutual manifestation. So in this one, the light waves are coming in to bounce off the mirror, the reflective power, and when that manifestation happens, the reflective power is still there, and the light now has a new direction. So why can't they? I think this setup is susceptible to aliasing in the discrete time world, because let's just pretend the mirror is highly responsive to 20 and very weakly responsive to 80, and shooting at 80. Well, we just saw if they're not sampling fast enough, if the reflectance isn't listening fast enough, then it will just take the 80 and reflect a very strong 20, which is what it's not supposed to do. That's against its essence. So we have a failure to fit. And we don't just want to say, well, just stipulate that it listens faster. Because now, if you say powers are listening, this is what Silas wants to regress on. Like, what are dispositions doing when they're not manifesting? You can't say they're listening, because listening is a power. So the reflectance power can't be a listening power. And then you can start asking questions, well, what is the listening power doing when it's not listening? So it doesn't work according to my assumption. So here's how I restore fit between the powers. It's pretty simple. You just slap the latest discrete time tick of the universe. This is a duration of time. It's a type of power. And you just put it in the constellation. This is Williams' term. When you have powers in spatial proximity, you make a constellation. And that way, everything's clocked in. So what I'm arguing, aliasing is impossible if reflectance knows two things. I have to use this weird metaphorical language about powers knowing stuff. And that's, I don't believe that everything has a mind, or, whether you believe that or not. I don't want to just put too much on that. But aliasing seems to be impossible if it's of the wave's essence, and reflectance knows that waves updates every tau, and that tau has indeed just happened. And so if we have this constellation where the power is clocking in that relationship, then I can trust that when I'm receiving information from the wave's power and it goes responding at 20 hertz, I can be confident that it really is. I don't have to worry that it's 80 hertz. Contravening my essence and violating the problem of fifth. So tau determines what kind of powers can exist and manifest. It determines what can even be on the blueprint. And for that reason, I call it powerful. It seems like it's something that can determine what's going to be on the map of the possible powers and possible interactions. Why wouldn't we just call that itself power? So that's where I'm going. Now, the strongest objection to what I'm doing probably is that you can take what I just said and put it on the other foot and say, look, you just erased the aliasing problem. Because you told us we have a tau this long, and if tau is this long, say 10 milliseconds, then the 80 hertz wave will never manifest in that world. You can't create the sinusoid fast enough. So you just erased your own aliasing problem. And this seems to be a total reversal of everything I argued. And then you say, well, so for that reason, just keep the figure 2 ontology, I call it. Just keep power off the blueprint. You can do it because you don't really have an aliasing problem. I call this the programming objection because it programming everything back into the power. And it's clean, it's sophisticated, it seems compelling on the surface, but I have replies. I think, first of all, I doubt that Williams or Power can really do this, so I'm going to send them back to the drawing board a little bit, and that's fine. That makes for a sort of interesting philosophy project, but I think a bit more strongly, I really don't think it's a good move for the explanatory role that powers are supposed to play in metaphysics. The powers are supposed to explain our observations and even according to Williams, the success of our science. Not that a blueprint will ever function as a science text, it won't. But for explanation, this is what he's going for. So, if anyone thinks I'm picking on them way too much, and we could just fly through some of their own claims, can a status quo polis really accommodate discrete time? Bauer's explicitly not there yet. He's taking Carnap's, I don't know if you say this Lin system, is that right? Does anyone know? Okay. And the Lin system is these signal relations across continuous time intervals, and they're explicitly the continuous time of the supernumerable continuum, so that between any 2 points of time and infinitude you can use to just smooth interaction of the powers of each other. And he does say at one point that space-time points have the power to be occupied by objects of property tokens, which is interesting. I could back him off maybe from my criticisms, but he stops short of putting time on the blueprint in any sense. So I think he need to clarify his stance if he's going to talk about the discrete time world. Williams is closer. He might have a shorter route to admitting his account. He's on his account on his face is very hesitant to ascribe power to time. He uses language like time merely passes as the object stages persist by their powers. He says an object stage is just the powers at any given time. If they have enough time to start manifesting, then that slice of reality is just an object stage, and that object stage will recreate itself through time, according to him. That's his persistence model. But time and all this time really passes. The spatial proximity is really important, but how important is the temporal proximity? Yeah, he doesn't really say a lot about that. Even more strongly, he says time is by no means an essential part of manifestation. It should be treated as contingent. So this is really language that speaks against putting time on the blueprint as power. Now, I think he's concerned about creating the kind of deterministic world that blossoms, even though he doesn't have to say the blueprint can tell you exactly what's going to happen down the line in the future. I don't think he needs to if you treat discrete time as a type of power. He mentions the time could be chunky, but it's more about the availability. And he kind of just offhandedly wonders, whether time could be an object. So if time's an object, well, it's not really a power in the blueprint. So I'm not sure if they can agree or disagree with me. But how do I reply? I have kind of a philosophy of science reply, and that's why it's not the mixed continuing metaphors. But, like I said, we posted these to explain the phenomenon. I'm going to say, if you now want to say the figurative blueprint and say that the EM powers are essentially discrete time powers, that they have that within themselves, this discrete time interval, it tells against their explanatory success. All our explanatory success is something in continuous time paradigm. So you're going to amplify the theory, these equations, Fourier analysis, it just gets cluttered when you don't have continuous time available. I'll say more about that in the next slide. And if the whole world is temporally discrete now, then the successful Fourier analysis, it's a mystery of what it's even referring to anymore, which I'll show. And the simplest answer is just scientifically premature to say that discrete time is baked into the reflectance power itself. Quantum gravity might get us there, but we're not there yet. There's people in quantum gravity who think that eliminates time, it just annihilates time, there isn't time. So, I just think it's premature to push forward the simplified blueprint as if the electromagnetic powers, they'll figure out discrete time themselves. You know, that's just thinking automatic. I don't think it is. So philosophers should interpret explanatory EM as conditioned by powerful time, which I think this ontology preserves. The EM power remains as we understand it, it's just now it is locked in discretely. That's what I'm promoting. Alright, and so what was I talking about before you? In the continuous time world, we get the representation F of JW by integrating over F of T. F of T is the continuous time function of the real world. And when we go to the discrete time Fourier transform, we're only reading samples. And we get a representation. But the representation, when you transform it back, it's not just going to tell you what the samples were, it's going to tell you what the continuous time signal was. So if there is no more continuous time signal, then it's really unclear what discrete time Fourier analysis is telling us. We already know it's like an idealization, but now it's like an idealized idealization. We're going meta-idealization here. So it's just becoming really strange. I'm not sure that for the sake of a parsimonious power ontology, you just want to say, yeah, Fourier is wrong, we're going to chuck it, and it's even longer than we ever thought. I just don't think we're there yet. I'm aware there are more transforms than just discrete time Fourier. But it's the same thing. When you talk about the discrete time at the input, there's none of these that are prepared to interpret the represented world as itself completely discrete. So let's go back to maybe some more commonplace philosophical objections. Bernie Ellis has some language where he speaks of time as a dimension of the EM powers. A categorical property plays a causal role without being powerful. And, I'm not going to start bringing in laws and bring in categorical properties. You can be a powers ontologist if you don't think that categorical properties are powerful. But it's just a dimension idea. Like, that's all it is. It's just a dimension. It's not powerful. And, you can define the laws of distribution. You don't just say laws of distribution if you don't believe them ontologically. He just, remarks time will not exist. The powers will not exist. And I think I've shown the exact opposite. I've shown you're going to have, based on what the time interval is in the discrete world, that's going to determine what your powers are. So he's kind of got backwards according to my view, and spatial-temporal separation between two objects is a real objective property, but its existence is not such a requirement to behave in any particular way. I feel like I've shown the exact opposite. Depending on what the delta tau is, it will totally determine whether you're going to alias or not. And some of us might know Alexander Berta's defended powerful continuous time based on his interpretation of general relativity, in that he sees a naturalist counterfactual relations between time and objects. And so it seems like, due to that trade-off, you need to call continuous time powerful. And a richer illustration of this, I can just read his quote: "The mass of each object is such that its disposition to change the curvature of space-time is that it changes the dynamical properties of each space-time point, and thus continuous time is powerful, this addition partner." Now he has detractors who say space-time does not causally affect bodies, it just determines which paths are available. I feel like I've shown more than an available path for the EM powers in the discrete time world. I've shown which EM powers can even manifest at all, based on what tau is. Tau seems to be powerful. So to conclude, as I said, I think Williams and Bauer would need to make some edits in order to incorporate discrete time in a component way. More importantly, I think the primary objection for bringing tau back into PM powers is premature for the three reasons I've gone over. The theoretical one, the theoretical version of not doing so, and the scientific prematurity, and then the problems introduced for our most predictively successful science, which is all based on continuous time for analysis. It just seems a little early to do that. And so, to preserve fit, philosophers should add discrete time to the blueprint as a power. And I want to thank William Bauer. This talk was inspired by, he gave a talk in North Carolina in January last year, and it troubled me so much that I went and bought his book and reviewed it, and ended up with this paper. So, thanks a lot.
Okay, so thank you very much. Now there will be comments by Luca Gasparinetti from the University of Milan.
You think so or no?
It would be great.
Okay.
You want the mic?
Can you stay here?
Sure.
Oh, thank you. Okay. So first of all, thank you for the talk and thank you for the paper. I think it's very clear and very well defined. So it discusses like one assumption for the blueprint metaphor in relation to the problem of fit. So I think it's very well done, directly to the point. I agree with your main idea. But for me, the crucial point is related to the hypothesis that time is discrete. And I want to ask you for some clarification on that. But before doing that, I think it would be helpful to start with some methodological notes, which I think that they will better clarify the assumptions of your paper. So there are three of them. So first of all, I know that there are some a lot of work nowadays for give a better characterization of what a power is. So in the literature, people are trying to provide a novel conceptualization of this, and I think that there are little indications on your paper on which thesis are you endorsing. So I think it might be helpful to put on the table your main thesis, because you say that, along with Williams, that you are treating powers as dispositions, but I think not all power theories agree with this view. So I think it would be nice to say, okay, here I'm a neutral, here I want to define power as disposition, but why? Or just say, okay, and this is just an assumption, you are happy with me or not, but okay, I will proceed with that. So I think it will be nice to at least address this a little bit literature in this case. Then another methodological notes is about time, and I think that time in general, at least in philosophy of physics, we usually consider time along with space in a unique four-dimensional manifold. So also, you mentioned time as a singular dimension, but then also in the Bert-Lugano's debate, you mentioned space-time as a whole. So I think it would be nice also to say, okay, I want to work with this specific account of space-time because there are some unities that I say, okay, I'm fine with space-time, but also other people like the separatists, we say, no, okay, space is one thing and time is another thing. So I think also it would be also nice to put on the table your idea on this debate. And finally, this is just a suggestion. Recently, people are working with the idea that some power theories are incompatible with metaphysical theories of time. So I wrote down the paper, so I can send you if you want. And yeah, I think that in this case, your paper it might be helpful also concerning this debate because you are trying to show that power accounts can be compatible either with continuous time but also with discrete time. Okay, so let's now get to the main point. So yeah, you say at page 3 of your paper that your purpose in this talk is to criticize blueprint holism for a sometimes explicit, sometimes implicit assumption. So I think that it would be super nice to include some quotation from your text. Because I think it's due to word limit, I think. But it would be great to add them. And yeah, here's the main point. You suggest that time is discrete, based your thesis on developments in quantum gravity. But then you suddenly move to electromagnetism, which is fine. But the problem is that, for me, that the assumption for electromagnetism is that space-time is continuous, not discrete. So I think that you need, so at least in the paper, also in the talk, you really don't justify this move from QG to EM, because you say, okay, if time were discrete, then this would create problems for the blueprint metaphor, since we need to attribute significant powers to discrete time. Okay, and I see the point about the consequent, but again, I'm less convinced about the antecedent, because again, I'm not sure why should we accept that, or at least why should we think that time is discrete in EM. Yeah, because perhaps I'm missing something, but the main idea also in the paper is that, okay, I agree. I completely agree that time might be discrete in quantum gravity, but then it seems that you are creating a case against you are creating an ad hoc case, because as long as time is discrete in quantum gravity, it's completely fine. But then you suddenly move to electromagnetism, and then I don't see why should I accept this assumption. And this is my main worry, because then if I said this, so if you provide me some reasons why I should go discrete time in electromagnetism, then I'm completely fine with your analysis. And then I have some minor comments on your idea of the late state tick, because I think, at least in the paper, there is no full-fledged characterization of it. But since we are working on classical electromagnetism, so we have to take a look at the physics in this case. So which ontology of time are you considering? Because you say the latest tick in the universe. So it seems for me that you are endorsing an a-theoretic approach to time. So like you have a continuous flow and you can slice the universe at one time, but then it seems to me that this is in a way incompatible, at least for the majority of people, with the insights from physics. So it would be great to hear from you both on the reason why should I accept the discrete time in electromagnetism, and also which is your ontological view concerning time in this case? Because also, one might ask if this latest tick time is relativistic or not. And also, since you're claiming that in a way this is what we should expect if time is discrete, so let's assume that one quantum theory of gravity is true, then we should also accept that time is discrete, but then in which way, so which metaphysics of time should I assume in this case? And obviously, again, if this state T is valid for all frame of reference or is like locally valid instead of globally valid. I don't know if I have.
We're well on time, so yeah, we are well on time.
Okay, perfect. Yeah, but I have so small comments. I think that you need to be more precise because there is an inconsistency between two footnotes. Because you said that you are accepting that powers are fundamental, right? Okay. But then in a footnote you said basically you're not committed to the claim that they are fundamental or not. So you are citing Bennett, I think. But yeah, it's a very small point. And yeah, I would also I would like to ask you, because you mentioned the wave particle duality in a very small sentence, but then I don't know. I'm curious to hear what you think about it, or if you are just neutral about this thing. And then the very last point, you said at page 13 that Bauer says that space-time is powerful, right? Mm-hmm. And yeah, it's not clear to me why it shouldn't be included in the blueprint if it is a power. Thank you very much again for the paper, and I will give the word to you.
Thank you.
Yeah, those are great points. I'll just be very brief. I'm approaching it. I'm trying to be, if those two books are all I've ever read about philosophy of powers, then that's all I'm going forward with. So, and maybe that's no good, but I don't want to make it so. The objection of how do you go from quantum gravity to classical, I'm just naively assuming that there is a possible way that quantum gravity would eventually tell us that everything in the world is, it discretely ticks by. And so if everything does, then everything we're calling classical EM does too. Now, maybe classical EM is only appropriate to talk about in a model. And so maybe that's kind of what you're getting at. It's not a real ontological commitment, but I'm just trying to sidestep that. And I guess it would depend what journal and what audience wanted to read this, about who would accept that or not. But yeah, that's a good point. Otherwise, yeah, that's probably all I have for that I'm prepared to say today. Thank you.
Yeah, can I add some, like very small, I don't know.
Yeah, right. Then I would like to open the floor.
Okay. A very small comment on this, because as far as I know, which is very legal, I know that, for instance, approaches to quantum gravity try to recover continuous space-time from a discrete space-time, so from a discrete structure, no spatio-temporal structure. So I think that if the hypothesis of discrete time works at the fundamental level, so to speak, then this doesn't work in the four-dimensional continuous level. So that's why I believe, at least as far as I know, that the shift from QG to the case of EM is not well justified, I think, because it really works if time is discrete at the fundamental level, but then you have to recover the continuous Lorentzian four-dimensional manifold. So
if you could point me to some references, I would appreciate that.
Yeah, of course.
Okay.
I have the file with me, so I will send you everything.
Okay, thank you. So, any questions from the audience?
Okay, I also want to come back to this point by answer to a concept. Right? Okay. Because it also seems to me that there are two notions of discrete time in our presentation. One is linked by quantum gravity theory, their motivation is that people think quantum field theory is fundamental, and you need a discrete language to describe those discrete words. Thus, you need this discrete language to describe the general relativity theory. Thus, the time is discrete, or space-time is discrete. And what we call continuous time in space just emerges as some non-linear level. But the case you mentioned from the electrodynamics, it's signal theory, right? To my knowledge, it's about how the EM rate is measured in a signal sense, because I do not know the technicalities. It seems to me, in this way. And the whole essence of this, it seems to me, is pure classical. And if you speak from the theoretical assumptions of electrodynamics, and to think about how that relates to quantum QFT, quantum field theory, is that it is a gauge theory, and standard model in QFT is also gauge theory. This is why electrodynamics is related to QFT, thus more fundamental than GRT. And the math we have to describe those electrodynamics is called differential geometry. And in that language, there is one basic element called basic space manifold. And if you see the assumptions underlying this basic element, it allows for the continuous space-time manifold, space manifold. So given this background, I think the whole classical electrodynamics is committed to the assumption that time is continuous. But what you mentioned in your presentation, it seems to me it's a totally different way of generating a new idea of discrete time. So I think there is a gap.
Yeah, I appreciate that, and I'm going to learn more about that. That's helpful. On the other hand, I'm thinking of the talk by Diego this morning where he challenged the idea that the formalism is going to tell us something positive about metaphysics, and so that would be kind of a smart aleck reply. But I can look at that gauge theory and whatnot. I obviously need to learn more about it. Thanks.
Next question.
Thanks. That was fun. This is something I don't know anything about, so I'm going to ask a question that kind of came up early on about the problem of fit. As I heard you, suppose you have two powers and they happen to be basically temporally related in such a way that it would make sense for them to interact and do something. And the problem of fit is to ask, why do they cooperate? And what worried me is I don't see how you can answer that question. If you put anything else in, the same question is still there. So putting on a clock tick is not going to help.
Right, so why would they cooperate with the clock tick? Kind of. Yeah. Thanks, that's really good. So maybe I just, change the nature of the meaning of why and the meaning of cooperate to rescue the problem. That's. I had thought of this. It's also going to come down to what is information, how is it stored, and is that especially if that's going to be understood in like the entropy sense, and are you violating the conservation of energy when you posit these powers around? And so I think that's tied together, but that's a very nice point. Thank you.
Hi, thanks. So I know a few other people have already said stuff about this, but I still have some worries about using quantum gravity as a motivation for discrete time. And I think that the worries kind of come in actually kind of sort of odd ways. So I don't know very much about quantum gravity in general, but I know a thing or two about quantum gravity in particular, which is a fairly sort of common framework that a lot of other approaches to the project are sort of built off of. And the way that they do things in quantum gravity is you start off with a classical general relativistic space-time, and then you sort of triangulate it, you partition it into these sort of finite four-dimensional volumes, and then you sort of quantize that in a particular way. And what you end up with is a situation where volume is discrete in the sense that there's a smallest eigenvalue for the volume operator that you associate with this quantum geometry. But that on its own doesn't actually entail that time itself is discrete, because time requires, to say that time is discrete requires saying that there is sort of a preferred foliation of this space-time, a sort of preferred direction in this four-dimensional manifold that constitutes the time direction, and that the sort of finiteness of this volume cross-cuts this particular axis in a particular way, which I don't think is guaranteed. But all of that aside, it seems like a lot of what you're saying relies really heavily on not just discreteness, but regular discreteness. So you really need it to be like a regular lattice of temporal points. So the sort of sampling heuristic that you gave is kind of like you sample the same amount of time, delta tau, every single time. But when you do this sort of triangulation of a general relativistic manifold, what you generally end up with, even if you end up with a preferred foliation where time is discrete, the gaps between the different moments will not all be the same. And I think you can't really say a lot in general about how regular those gaps between the moments are going to be. So my question is really, to what extent does your proposal depend on the gaps between the moments being the same length? And if you can say something about how things would change if the gap between the moments can differ.
Yeah, thank you for that. I was envisioning a worst case about the existence of sinusoidal powers, and if that kind of gappiness would filter even harder and say there's even fewer high-frequency things that can exist. I think what we start bumping into is that the estimated length of tau that they're going for is the like 10 to the minus 43 seconds rate. I mean, it's so fast that it's way faster than any usable signal we're talking about. So would anything in nature really exhibit aliasing at the powers level? And yeah, that's interesting. I'm trying to avoid, I have space for one paper, so I'm trying to make one small point. But that is helpful information about doubts about the universe ever lining up regularly all the way down. I hadn't thought of that, so thank you.
Okay, thank you. So, time for one or two questions. One or two more questions. Okay. Whatever you want to do. Okay. Yeah.
I have another point that you might appeal to electrodynamics. Because we talk about reflectance, according to electrodynamics, the mechanism of EM reflection is that there are oscillating dipoles. So when they are in synthetic light, there are electrons bounded, electrons they move, they serve as oscillating dipoles. I think there is a point to make that oscillating dipoles are not disposition. So in this case, your opponent cannot account for this. How do you evaluate this direction?
What was the last word you said? Dipoles are not what?
Oscillating dipole.
They're not oscillations?
The bounded electrons, they oscillate due to the incoming wave.
Right.
And they radiate back. There is a sense to argue that these oscillating dipoles are not dispositions or manifestation of dispositions.
Right. That's dipoles are not dispositions. Is that what you're? I just can't quite hear them.
Because they are purely light. The essential feature of dipoles are frequency. The frequency is determined by the incoming light. This is not something that the disposition can explain.
Okay, so they don't have their own powers to do anything. Okay, yeah, that's very interesting. So I I could blow up the resolution of reflectance and where do the powers stop? Where do powers have to stop existing and where is it not really a power anymore? That would be fascinating. I was just using naive stuff from the literature. I was just taking published accounts, and that's a great point. Thank you.
Okay. If there are any more questions, I would like to close the session here and thank our speaker for coming.